What's going on, guys? Welcome back to this video. Today we are gonna talk about network forensics, and specifically we're going to use the prominent tool Network Miner to demonstrate the use cases of network forensics. So basically, first let's start with network forensics. So what's the definition of network forensics? So in network forensics, we investigate the network traffic. So network traffic. That's what we are interested in when we perform network forensics. Network traffic comes in two forms. We have live network traffic and we have recorded. Now, the thing is, network forensics is concerned with analyzing both live traffic and recorded traffic. So live traffic, how can we analyze live traffic? So basically, to analyze live traffic, we use real-time network monitors. For example, your firewall, your IDS, okay, have built-in features to perform real-time monitoring of the network and report anomalies. Additionally, one of the other methods to analyze or to observe or monitor live traffic is to perform full packet capturing. Okay, so there are specific programs. Okay, even sometimes IDSs or network solutions or security solutions can do full packet or real-time full packet capture. But the thing is, real-time full packet capture for live traffic is we have actually two downsides. First thing, it is time consuming. And it is resource consuming. So basically, you're gonna need a lot of space. You need a lot of processing, right? Because usually when you are capturing the network traffic in real time and then you are saving these as packet captures, you will need space and you need processing. So that's why usually instead of full packet capture, we actually use net flow capturing. So in net flow capturing, we capture the state of the traffic. We don't dive deep into the payloads exchanged or the data exchanged. That's the difference between full packet capture and net flow capture. So usually security solutions such as IDS, you can turn on net flow real-time capture of live traffic. So later on you can actually analyze it. So that's live traffic. Now recorded traffic, it is the captured form of live traffic. So when we capture live traffic and we save it into PCAP files, we call it recorded traffic. So recorded traffic come in saved packet captures. Usually the files have .pcap extension. So .pcap are recorded traffic packet or packets that have been recorded using sniffers, security solutions, IDS, packet captures, so on and so forth. So here now we come to why do we use network? Why do we analyze actually network traffic? What's the purpose of doing all of that? So what are we trying to achieve here? So basically in network forensics, we aim to achieve first, we want to perform network discovery. One of the use cases of network forensic. Network discovery, we want to find out the hosts on the network. We want to find out the ports, the services running. Sometimes we want to find out the servers. Example is finding out the DNS servers. Example, finding out the connected devices such as maybe switches. No, actually switches cannot fall under servers. It's gonna just say maybe servers, DNS, file servers. We may also want to discover connected devices, so network devices, such as, switches, firewalls, so on and so forth. So network discovery. So how do we perform network discovery? Is by capturing live traffic or recorded traffic. We analyze them and we extract artifacts. We extract insights from which we can find these parameters: host, port, services. The other thing about network forensic is packets reconstruction. So how do we reconstruct packets? So basically we mentioned this earlier. So here we have the live traffic. Okay, when we perform packet capturing on the live traffic, we can extract the PCAP files. The PCAP file, from the PCAP files we can build the packets over, or we can start over and analyze the traffic. Therefore we can reconstruct the packets and the exchange, or the flow of exchange that actually were taking place during the live traffic. We can detect data leakage. So in data leakage, we actually, by analyzing the recorded traffic or the live traffic, we'll be able to determine what is being exchanged, the data being exchanged. Okay, during the exchange of packets, we'll be able to see the payloads. Now, number 4, we can detect, which is the most important aspect of network forensics, we can detect malicious activity. So by analyzing, so basically here in network forensics, usually we analyze first who conducted what. So by who, we analyze the source, destination, IP addresses, hosts, DNS names. Okay. Next, we analyze the data. Okay. What are the packets? What is the data exchange between these IP addresses or these hosts? Now, again, we analyze, most importantly in forensics, the timestamp. And of course, by analyzing the data and understanding from which IP address it was originated and to which IP address or which host it was sent to, we can extract insights. And from the insights, we understand what happened and why it happened. So that's a general overview of network forensics. Now let's go over Network Miner and find out why Network Miner is a great tool to conduct network forensics. So we can open a new page here and talk about Network Miner. So Network Miner has 2 modes. We have sniffer mode. Okay, so in sniffer mode, what we do here, we actually sniff traffic. And from the traffic that is sniffed, we can convert the live traffic into recorded traffic or packet capture. And there is another mode beside the sniffer mode. It is the data processing. Okay. Now the core function or the core feature of Network Miner lies in the processing. So this is the strongest or the strong point of Network Miner. But sniffer, it is not that good. I mean, it wasn't dedicated, or it wasn't created to be a sniffer, but you can perform simple sniffing with Network Miner to create packet captures, but it wasn't created to be a network sniffer. You can say it is a weak link here. Alright, so in processing, what we do here, we supply Network Miner with a PCAP file, Okay, and from the pcap file we can extract artifacts and information. So here comes the strong part of network miner. So from uploading or supplying or importing a pcap file to network miner, okay, we can extract information about first hosts. So from the pcap file, network miner has a friendly interface where we can see the hosts. We can see details about the host, such as, for example, the ports open on every host. We can see the OS operating system installed on every host. We can also find out the traffic flow. Okay, example is how many number of outgoing packets, number of incoming packets. Right now, addition to hosts, we can see the frames, analyze the frames. We can analyze the files. So basically, during the network communication between two hosts, for example, if there are certain files exchanged between two hosts, network miner is able to extract these files and present them in a friendly interface, not like Wireshark. We can extract credentials exchanged in clear text. We can extract keywords. We can extract DNS queries. So this is the power of network miner. We can have insights, easy to access insights. At the same time, they're easy to interpret. You don't have to dig through the packets and apply filters like Wireshark. So the power of network miner lies in the processing. On the other hand, the sniffer is a weak part. I mean, it's not supposed to be used as a sniffer, but still you can use network miner to sniff maybe packets in an easy mode. Let's say packets exchanged between couple hosts on the network. If the network is small, you can use network miner to perform sniffing. But if you want deep dive or detailed sniffing, you can use Wireshark. So Wireshark viz network miner. What's the verdict here? So network miner, we can use network miner here, miner. Okay. 2 for the analysis. Wireshark, it can be good to create full packet capture. Still, Wireshark can be used for analysis, but you have to understand the filters. You have to perform deep dive into each packet. But network miner has a friendly interface where it can present all of these insights. So coming back to network forensic here, an example of using network miner in a forensic scenario is, say for example, you have an incident and a machine that is compromised. Let's assume that your IDS, okay, or at the time of the compromise, the IDS has created a packet capture. Then you can have the packet capture over here, import it to network miner, and extract all of these information. So basically, network miner is good again to capture what's called the low hanging fruit. So it gives us quick overview over what happened, who did what, and what has been transferred or exchanged by providing this quick overview over these parameters. We call this the low-hanging fruit. Okay, so we can use network miner for quick analysis. All right, now let's go to a practical scenario and demonstrate all that in action. So to demonstrate the practical part of this video, I'm using a room named network miner, the room from TryHackMe, and it is part of the SOC analyst track. All right, so we're gonna start by answering the tasks. So I'm gonna start from the very end, because for every task or for every scenario, you have a pcap file to analyze. Now I'm gonna start with task 7 pcap use case or use case 2. So the case 2 pcap, I'm gonna start with it because it's the heaviest and largest pcap file. I'm gonna start with this. So first, let's provide an overview of Network Miner before we answer the questions. So in the host part, as you can see, or first in the file menu, we can import a file using the open. You can browse to the PCAP file that's provided in the scenario. Or we can import over IP. But most of the time we open manually using the open option here. Tools. In the tools we can here do limited aspects or limited things such as clearing the interface or deleting the captured data. So on the left hand or on the right hand here we have the case panel where we have the PCAP file that we have imported along with the MD5 hash of this file. So when we go to tools and clear the GUI, you're gonna still have the PCAP here, and by clicking on reload case files we can retrieve the information back. But if we click on delete captured data, the file will be deleted from the case panel along with the information here. So in order to retrieve the information back, we have to go again and retrieve the file or navigate and open the file. The help menu is for checking for updates. Alright, now let's go to the tabs here. So the hosts, again we explained the board, the host gives us information about the discovered devices. They could be endpoints, they could be network devices, they could be phones, they could be anything that can connect with the internet. Along with information about each host. For example, we can collapse this and view the IP address, the MAC address, the OS, and we can see here the open ports, in addition to statistical information about the bytes exchanged on every port. Additionally, we can see the sessions created and the host details. If we go to files, we can see the extracted data. This covers all sort of data, all sort of files, HTML files, image files, PDF files, certificate files. So here you can see the extracted files. If you go to images, here we can see the extracted images, self-explanatory, right? Messages, here we can see the emails. If there are email exchanged in the traffic, okay, we can see them here, and we can see chats if they are in clear text. Credentials cover cookies, cover hashes, clear text passwords, and sessions here. This is the established sessions between hosts. Okay, now this covers the established sessions on various protocols, as you can see, HTTP, POP3, and DNS. Here we can see the DNS queries between hosts, and for every query here we can see the server, okay, the port, timestamp, and the client or the device that initiated the DNS query. This is very helpful if you want to investigate a compromised machine and you want to find out if there is a certain machine that is communicating with a T2 server. Definitely it's gonna use DNS to carry over the communication. Okay, so here we have the parameters. This includes the parameters exchange in the request. For example, you can see here the parameter HTTP parameters, get, request, user agent, host. So for every protocol we have parameters. We can see them here. And the keywords, here we can use the keywords to apply some filters, but it's recommended to use the keywords before you load the PCAP file. Now if I try to apply a keyword such as USB, because it's pertinent to the current scenario, we can click on add. As you can see, we have a statement, please add keywords before loading a PCAP file, or press reload case file. I'm not going to press reload case files because again guys, this file is big file, and it's going to take some time to reload the related information. Going to anomalies. Now in the anomalies here, we can see information about security issues, but the anomalies section is a new section that has been added to Network Miner. It wasn't present in versions before 2.7.2, but they added the section here to detect common security issues and common exploits. Okay, so if there is exploit attempts or security issues being detected or was detected in the exchange of traffic recorded in the PCAP file, we can see them here, but it is not a comprehensive, it cannot be used to cover everything, right? It's just common security issues, common exploits such as the eternal blue exploit, or maybe default configurations. They can be, detected here if the traffic, the PCAP file that we captured happens to have these security issues in the capture. All right, so we're going back here to the questions. I'm gonna start with task 7 again with case 2, which is the current file we loaded. What is the USB product's brand name? All right, going back here to find out the USB product, we can go to files because it cannot be found here. It is not a host, right? We can go to files, and maybe we can use the keyword filter here. Now, before using the keyword filter, we can see, as you can see here, in the file name, we can see files named usb.zip, but still this doesn't give out the brand name. So you want to search for the word USB and use it as a keyword, apply, and we can see all of the files in addition to the frame number with the keyword USB detected in them. So we can see many here. Now we have this one, frame number 13,411. The file name highlights high speed USB. Okay, so this might have the model of the USB. If we go to file details, okay, we can see quick overview of the file. Let's open the file. It's an HTML file, so we open the folder. We can see the folder storing this file. We go ahead and open this file. Now this is an HTML file. It might have information about the brand name, because this could be a recorded attempt of someone trying to buy a USB or at the time of capturing the traffic. So let's see here. The machine is kind of slow, but we're gonna find the answer here. It is A6. So basically, without opening the file, you can again take a look at the source host. Yeah, it opened here. The file couldn't be accessed for some reason. All right, so let's go back here. We can see here that the DNS resolution of this IP address resolves to this domain name. If we try to access this domain name, as you can see, it's really an electronic brand, which is the brand of the USB. What's the name of the phone model? This one is a bit tricky, but you can find the answer in the images section. You might try to filter with the phone keyword here, but you're not gonna find anything. Let's try with phone, apply. So you have one entry here. It's an image file, but doesn't have anything. Let's go to images, and maybe here we can look for an image that has a phone inside of it. Okay, nothing so far. Okay, so here we go. Up there we have. Okay, so here we have some laptops, PlayStations, This one looks interesting. Let's go over here and open the image, see what is that. So this is a phone here, but it doesn't have much information about what is that phone. Scrolling down, and that was it. Now if we try to open the folder containing these files, here we have a phone here, that we have this one, open image. And in the image name, we can highlight this Lumia 535. All right, let's go to the files and filter for the word Lumia. Apply. And we have two entries. This one we already opened, and this one we can try and open this file again. So in both files we can see Lumia, the word Lumia, right? But in the previous one we can see 535. So 535 could be the version of the cell phone or the model Lumia 535. Exactly, this is a model number. So this is the answer for this task. What is the source IP of the fish image? Okay, going back here to the image section, again we can search through the images and look for a fish image. But we can be a bit smarter and search with the word fish, because the name of the image could hold the word fish. So crazy fishing, and the source host is or starts with 50 and ends with 9. What is the password of this email address? So again, the passwords can be found in the credentials section. We can highlight the password column and we can look for clear text passwords. You can see we have one and it corresponds or belongs to this email address. What is the DNS query of frame 62001? You're gonna have to go to DNS queries and search for the frame 62001. You can see here that the DNS query, this DNS query, so it's trying to reach this domain name or this subdomain pop.gmx.com. That's the answers for PCAP2. Now let's go ahead and load PCAP1. So I'm gonna click on delete captured data and go to file, open case 1. So in case 1 we don't have much information, as you can see. So let's start with answering. What's the OS name of the host that ends with 122? So we highlight the host ends with 122, and we can see that the OS here is Windows, but we want exact information about the version and the operating system, so on and so forth. So I can see it is Windows NT4. That's the OS. Investigate the hosts 122 and 91. How many data bytes were received from 91 to 122 through port 1065? So to answer this question easily, first understand the logic of or the direction of the packets. So as you can see here, the bytes received from 91 to 122. So we can start with 122 and look into the received packets, meaning the incoming sessions. So we have incoming session 2. As you can see, we highlight this or we collapse this. So you have 2 incoming sessions from this is the server and this is the port. Now we take a look here. Again, we can see the server that ends with 122, which is the IP in question. As you can see, it has received 122 bytes. So received from host 91. This is the host 91, client 131, 151, 32, 91, and we have 192 bytes sent from this IP address. Alternatively, you can answer this question by going to the IP address 91 and going to outgoing sessions. on port 1065, and we can see it has sent exactly 122 bytes. Let's see, where is that? So here it's not mentioned correctly. Let's see. This covers the IP address 117. We want, well, yeah, okay. So it was the wrong IP. So outgoing sessions, highlight the correct IP, and we can see again 192 bytes. This is two ways to answer the question. Next one, investigate 122 and 21. How many data bytes were received from 122 to 21 through port 143? To the host 122, we can investigate the outgoing packets. Going to host 122, outgoing, you can see there are no processed outgoing sessions. Okay, so we're gonna circle back to host 121 and highlight the incoming sessions. So going to 21, incoming sessions 0. How many bytes were received from host to 21? Okay, let's click on outgoing, and we can see there is one session opened with the mentioned IP on port 143, and we want to highlight how many bytes. We can see there is 20,769 bytes. Alright, what's the sequence number of frame 9? Going now to frames. Alright, so this is a version 2.7. Thing is, in version 2.7, it doesn't analyze frames, so you have to open version or previous versions. So you're gonna go back here, open version 1.6. And here we load the pcap file. So as you can see, we have the frames. So there are certain version differences. The anomalies and the frames. The frames don't exist in versions after 1.6. So the frame number 9. So frame number 9, we want to find out what's the sequence number of frame number 9. So in TCP, the sequence number is exchanged in the TCP header, and we can find the answer here. What is the number of detected content types? Alright, content types, we can go to, this is pcap 1. Alright, we can now go back to version 2.7. And here we can check the parameters, because the parameters section do not exist in versions previous to or prior to 2.7. So we cannot find out the exact answer if we open it in version 1.6. So content types, we can search for the content type, and we can highlight case sensitive. Why? Because as you can see, that's how it is written here, content type. We want to find out how many content types. Up until now, we can see only text or plain text. We want to find out the rest. We're going to create a filter that exactly matches the lowercase and uppercase letters here. So apply, and we have text and multi-part. So we have two content types. All right, this is for task 7. Okay, now there are other tasks that cover the overview of both versions or both tools. So we're gonna open overview 2 and use the MX7 pcap. So we're gonna just here delete file MX7. So let's now search with 63,075, apply. We have one file, and indeed it mentions the Linux distribution. So there was a file downloaded from this host, and the host resolves to send OS. What is the header of the page associated with the frame number 75,942? Again, we can filter the frames using the Files tab, Apply. You can see one file. To find the header, we can have to open the file. Or first, let's open the folder, and from here we can open the file, index 1. And the header says password nedab. That's it. Okay, what is the source address of the image? Okay, so now we can take the image and filter with the name this time. Okay, there is nothing here. What is the source address of the image? Okay, we go to images. It's gonna clear the filter on the files tab, and we switch over to images tab. So here we want to perform some search, but looks like we cannot do filtering, or there is an issue here with the program. Let's see. Let me filter with the name only. Let's take this out. Yes, this is it. So what's the question? What's the source address of this image? Meaning, what's the address that requested the image? So it starts with 80 and ends with 187. It can be found under the source host. What is the frame number of the possible TLS anomaly? So we were talking about security issues. Security issues can be found in the anomalies tab. And we can see indeed we have two TLS boundary issue. The first frame number is 36,000 and the other one is 73,000. So it's the first one. And now we're gonna load the MX9. Gonna click on delete, open MX9. Hopefully it is not that big. Okay, what are the questions here? Look at the messages. Which platform sent a password reset email? And other question, what's the email address of Branson Matheson? Okay. And the last task we're gonna go over is, I think it's task 4. It has questions. And the other tasks are easy. So version differences, let me see. So which version can detect duplicate MAC addresses? It's 2.7. Which version can handle frames? 1.6. And which version can provide more details on packet details? 1.6. So here we're talking about version differences. Some features are available in 1.6, some features are available in 2.7, which means upgrades and updates don't mean always extra features. They indeed come with the new features, but sometimes they cancel previous features, which we can see here in version 1.6 frames and packet details. Okay, going back to the original task that we were handling. So, alright, so we want to find out now the password or the platform on which the password reset email has been sent. So look at the messages. Which platform sent a password reset email? So we go to messages section and we can see 12 messages. They represent the emails exchanged in the packet capture or between the hosts captured in the traffic. So we can see there is one platform, because the question is asking the platform. There is only one platform, regardless of the type of request mentioned in the message, which is Facebook here. The other one, what's the email address of Branson Matheson? So you can see their email address is bransonsandSite.org. Okay, so this is task 5. Going now to task 4, which is the last task of this video. I'm gonna open the MX3, but this time we're gonna open with version 1.6 because this is the version highlighted in this task. It's gonna go ahead, version 1.6, and now open the file mx3. Oh, luckily enough, quickly analyze the file. So what's the total number of frames? When we go to frames, and we're not gonna count them, we're gonna just scroll all the way down to the last frame, which is 460. How many IP addresses use the same MAC address with the host 203? It's gonna go here to host. We have 8 hosts, and we're gonna go to the host that ends with 203. So this is the MAC address of this. Come on, man, load this. Okay, so this is the MAC address, ends with 100. Our task is to find out how many hosts have the same MAC address. Gonna have to analyze every single host. So 100 has different MAC. We're gonna have this other one. It has the same MAC address, the host that ends with 223. Okay, gonna collapse to 37. Take a look at this. Not the same MAC address. Also, this one is not the same. 129. Also different MAC address. And lastly, the IP address that ends with 99, it has the same MAC address. So total we have 2 MAC IP addresses, or 2 hosts with the same MAC address as 237. So we have 2. How many packets were sent from host that ends with 223? So we're going to take a look at this host. 223. How many packets were sent from this host? So it has sent 4 packets. Or how many bytes? Sorry. How many bytes? I'm going to collapse this. And we can see 696, but here I answered differently. Why 72? 223. Oh, this is the wrong IP. This is the IP supposed to analyze. You can take a look at the sent packets. We have 72 packets exactly. How many packets sent are 72? What's the name of the web server banner under host or under the same host? Gonna take a look at the host details. You can see it has the web server type or the web server software. It's Apache. MX4. Delete the captured file. Open a new captured file. MX4. What is the extracted username? Okay, here's the thing. In version 1.6, as you can see, the credentials section is empty. And the only way to find the username or the password for the next question is to go over the credentials tab, which looks empty. Now, if we open the same file with version 2.7, and try to analyze the file one more time, go to credentials, and we can see the credentials, the username and the hash, but they couldn't be found in version 1.6. So that's the thing. So always use up-to-date versions, but if you need specific insights on frames, you might be you might need to use version 1.6. So that was it, guys, for this video. I hope you enjoyed the tutorial, and I'm gonna see you in the next video.